Hello everyone, myself Niranjan. In this video, I'll be presenting my internship as projects. In this as presentation, I'll be going through the things which I learned from an embedded system virtual internship, which was conducted by Extreme company. And yeah, in this internship, the main thing I was learning is most advanced EV systems, embedded EV vehicles. Let's go into it. Yo, this is the hardware setup from the internship which I used. The main thing I used is STM32CubeIDE. In this IDE, I used to create my and code my C embedded C codes, and this was very handy and useful for my embedded system knowledge. In this internship, teachers and lecturers they taught very well and explained how can I write a complete C languages. And using this STM32, I used to write code and compile. When I compile, I used to get binary files. Those are executable binary. Using those binary, I have to simulate the output. As this is virtual internship, I didn't have to buy any high cost ARM32 or ARM Cortex M3, all those sort of hardware thing. What they did was they made us use PC Simu Labs, which is an simulation software. In this, I used Blue Pill 32 ARM board, which is an ARM Cortex. That was very useful because I had done many things. And yeah, let's come to our architectures. In this internship training, I learned many things about ARM Cortex, embedded systems, and microchips. ARM Cortex A. This is very often used in mobile phones, and you all know how high performance and how very fast the ARM Cortex A is. And ARM Cortex A R. This ARM Cortex R is very critical because these ARM Cortex R are used in very higher places like automated EV, and then in emergency real-time embedded systems. And then let's go to ARM Cortex M. In Cortex M, this is a normal, not normal. We use it in low power. Uh, let's just say we use it in educational field to teach about ARM Cortex and then ARM architectures. And then next, let's come to our main plans. Here, how I designed my EV dashboard is first they taught us how to build a step by step. Let's see the architecture. The first part was an analog and waves inputs, which I generated through simulations in PC Simu Labs, and in that I used potentiometer to give the inputs such as accelerator, brake, SEO. SEO is nothing but state of charge, and temperature. All those things I'll be giving it to the input, and then the hardware part. Here, the MCU is nothing but the binary file which is generated from the C program. The C program in this internship they taught us the finite state machines of EV. They thought it very clear way, and then it was very useful for me. And then finally we developed a Python dashboard, a Python dashboard that used to tell the outputs and then simulate the actual experience of the program. I'll be showing the demo in further slides. And then yeah, this is my favorite part, ultrasonic sensors. In this, I developed my own three ultrasonic sensors reading value program, which was my one of my assignments. And here, how does ultrasonic sensor work? In this, as you can see, there are two round balls. This is nothing but um, sound blasters. Those one of it sends wave, and then another one sends it. This is trigger, and trigger in the code I used to set this pin to high for at 10 microseconds, and when the signals pass through 10 microseconds and hits the object, the ultrasonic sensors will be coming back and then hitting the trigger points, and the overall time will be calculated and then used stored in the program. And yeah, the other pin name is echo, and the echo states high as the waves travels from this sensor to and then hit some objects and then reflect back throughout the whole play. This echo pin will be high, and how actual thing will be calculated is here we have a golden formula. Distance. Distance will be calculated by time. The time which was set from high of the trigger, from the starting point of the time will be uh, releasing the pulse from the ultrasonic sensor to the object, and then coming back from the object. Yeah, and then speed of sound, as you all know, this is the speed of time in centimeter per microseconds divided by 2. Why do we divide by 2? Yeah, because the wave, the time was calculated from the sent and received. Because this is two way, we'll be dividing it by 2. And let's go to our ADAS system. ADAS, yeah, this is something very useful nowadays, and even for AI assistant. And yo, let's go. Here we had certain speeds and then distance. When the speed is high and then the distance from the other objects in the sense car, uh, all those distance will be calculated from ultrasonic sensors, as we discussed earlier. Here the ultrasonic sensors, here you can see how many centimeter it goes, from 20 centimeter to 50 centimeter, all those things. And then this is the speed value. As the distance is closer and the speed is higher, the ADS system will give critical stage. We have the accelerator goes off and then start regen mode, and then warning stages from 50 to normal speed. And then, as you know, the safe, we have much more larger area from the vehicles around us, and then has less speed or higher speed. Yeah, let's go to our diagnosis advantage. One is as V3 we have three time. One was safe zone, warning stage, critical stage. In this safe stage is advisory, where the abstracts or blind stage are more than 30 centimeter and has speeds around 20 kilometer per hour. And this will we demonstrated it using lights. I'll be showing those demo. And this is the final state machines which I learned from this internship. Here you can see from the park stage, how it goes to ready stage and auto transaction to driving stage. And if something gets overridden, the machine automatically goes to fault stage. And when the driving is on, SOC gets consumed and the charge gets reduced. We even coded all the things manually and know how actually the code works. And this is the break and recognized and when we apply brake, the SOC get recharged, replenished, even those things we programmed in our code. And yeah, before I tell this, as I use Mac now, I I used Windows Windows PC, the which was very low spec. In that PC, I used to run my internship projects. That sadly now it doesn't work all of a sudden. Like when I was creating my Python dashboard, the CPU got overridden and got overbrushed, and then now the computer doesn't work. Yeah, like the spec was of the PC was i3 Intel processor. I'll be showing the pictures and then demo video. I luckily had the demo video of my first assignment, and then yeah, I'll be showing this dashboard. This is the dashboards. I luckily had the screenshot of my uh, PC Simulab and then dashboard screenshot. Here, before we go, we will talk about the fault escalation. As you know, the fault, we have three kind of fault. We created three kind of fault. One is overheating, when the temperature goes beyond 120 degrees Celsius, and then the low battery charge, which code is 002. All of these are hexadecimal number. A low SOC charge, like when the battery percentage is below 5, we get this fault code. And then collision, when the threshold limits, yeah, when the car range is in the red range, we'll get collision code. And then action it will be taken by is immediately suspends the driver. It will set the motor. And yeah, this is the dashboard which we created, and here you can see the speed, SOC, state of charge, TMP is temperature, and fault. The fault codes are 001, 002, 004, and I'll show you the dashboard. Here you guys can see this is the dashboard. This shows the speed which I can control it by this. This is PC PIC simulation lab. Here the space parts are potentiometer, and these are three uh, ultrasonic sensors. These three ultrasonic sensors are the distance around this car. This is our EV vehicle. Here, one, two, three. All those three blocks are surrounding cars, and those distance will be covered by these ultrasonic sensors. I'll be manually increasing and decreasing those things. And then this is the light sensors, which will tell the states, like whether the car is in danger mode, all those things. When this is the accelerator pedal, when I increase it, the speed get increased, and then car starts moving. And here brake, when if I click the brake, the speed will gradually reduce, and SOC will gradually increase, because we even programmed um, we even programmed region function in this thing. And then this is state of charge. We can even reduce the charges, and when the accelerator is high, gradually our battery reduces. And if we change this toggle bar, if we decreases the distance, this car gets closer and then gives her alert. Yeah, before that I'll show my assignment. uh, I have only this video, and as you can guys can see, this is my old PC, which is very old. And as this is Mac, I couldn't download PCS sim, because the PCS sim is not in the Mac applications. Here you guys can see this is my code. I'll forward it to a little further. I just explain here. You guys can see that this is three ultrasonics reading pins. Um, the GPIO 0 will be read by this sensors, and then GPIO 2 pin will be read by this sensor. I had created my separate three functions. This is before this I'll show you one my main function. I just created my one function that uh, calculates the real sensors value, and then call that sensors with giving two and three different pins from the sensors, and this will be just printing all the sensors, which this is just in my assignment, and I'll show you the output. Yeah, wait a sec. You guys can see the date of this. This is recorded at June, yeah, 6, 22, 22 of June. This is on 24th. I had to upload my assignment, which I already did. I'll go to big screens. Yeah, here we can see. Wait a sec. I'll be yeah. This is now. This is STM32, and here this is PC simulation lab. In this, I'll be simulating my code. Wait a sec. Yeah. Now, it's already. I already attached, uploaded my binary file, extracted my zip file. Here, this is the blue pill PC sim. Uh, I already configured it, and this is the virtual terminal. This this using this, I'll be getting the virtual terminal output. Here you guys can see sensor 1, sensor 3 outputs. This is yeah. See, if I increase this, the output will be changing here. As this was the thing I learned from this project, and yeah, this is my overall presentation. I thank Emergent team for giving these opportunities, and thank you.